All right, good morning. Happy Thursday. Today we are kind of shifting. We've totally finished now the first section of Unit 4. So parametrics are finished. So the things you need to understand about parametrics are how the graphs look and how they work, how everything is dependent upon the third variable called the parameter, time, which could also be other variables, but in general it's time. You need to understand how to find the slope and how to find the second derivative parametrically. You need to be able to write the tangent line if given the time and the tangent line if given the point. You also need to be able to find intervals of concave up, concave down, increase and decrease. And then you need to find where they're horizontal and where the function is vertical. And then parametric arc length as well. All right, so polar, we're kind of going to do the same thing now. We're going to go through 2 days of just, or 1 day maybe, of just polar coordinates and polar graphs and what they are. You learned this once upon a time. It's been a while, so maybe you don't remember it anymore. But we are going to go through that today, and then we'll start talking about the calculus of it. The calculus of it will be similar. You'll find slopes. Now you're going to find area. That's probably the most important thing from this whole unit as far as the FRQs on the BC exam go. Is being able to find the area. All right, but let's look at what a polar coordinate system is. So polar coordinate system, you might at least remember that they worked on this spider web thing. That's what most people say. So instead of an XY plane where your variables are controlled by your X and your Y, now you're going to be given an R and a theta. So R is your distance from the pole being the origin, and R is a directed distance. So if R can be negative now, and if R is negative, that means you're walking backwards, if you will. And then theta is the direction you're facing. So the first thing you learn how to do in Excel Geo when you learned all these things is to graph some dots. So for instance, letter A says that the radius or the distance from the origin is 2, and theta is pi over 3. So what you do, and the way I think about this, so you're essentially standing here on the pole. So you face pi over 3. So pi over 3 is your direction. So we're going to face that direction. And you're standing on the pole. And you're going to walk r units towards that direction. So you're going to walk 1, and then 2. And then so there's your dot. Now these are not connected. So you shouldn't actually connect to the origin. But there's your dot. So you're facing pi over 3, and you're walking 2 units towards it. Some people are really good at this. Some people, it takes a lot of practice. So if you need more practice thinking about it, there's a lot. Just Google YouTube graphing polar coordinates, and there'll be tons of videos about it. So little weird things. So B, you're facing towards pi over 6. So that negative pi over 6, sorry. So that means you're going backwards from 0. Okay, and then you're going to walk 3, 2 towards it. So 1, 2, 3. And I'm starting from the pole again. So 1, 2, 3. Now, this is where I would stop and make you come up with different ways to label that in class. So think about how else could you label that point so that it would be the same point, but it would look different in the polar coordinate system. A few answers that you would come up with would be 3, comma, and just going all the way around 11 pi over 6. So that would get you to terminate at the same point. And the more complicated one, which we're going to talk about in C. So we'll come back to that one. So let's look at C. So C says your direction is pi over 4. So if I'm facing pi over 4 is in here. But my radius, or the distance I'm going to walk, is negative 2. So I'm facing this way. But instead I'm walking backwards. So I'm going to walk backwards 1 unit, backwards 2 units. So that's where my actual point's going to be. So again, you're facing towards pi over 4, but since your radius is negative, you're actually moving backwards 2 units. away from where you're facing. So with that, we come up with the other way to label letter B. So if I want this point, you could say you're going to face 5 pi over 6, and you're going to walk backwards 1, 2, 3 units. So you could say -3, 5 pi over 6. And there's all these little tricks about like add pi and flip the sign and all this stuff. I'm not going to really get into all of that because it's better if you just understand it and can look at it as well. So C, this is where in class I'd say stop and come up with 2 other ways to label C. Somebody would come up with, well, use a +2 and look at 5 pi over 4. So then what that means, like you're facing 5 pi over 4, and then you're just going to walk 2 units towards it. All right, so that's graphing dots in the polar system. All right, now we got to be able to go back and forth. So we got to be able to move from rectangular systems to polar systems and back, just like we did with parametrics. It all comes down to right triangle trig, once again. Because any point is just, it can form a right triangle with the XY system. So we got theta here. Your radius is your distance from the pole. So there's x and this is y. So x is just r cosine theta. Y is just r sine theta. That's just right triangle trig solved for x and y. Tangent theta is y over x. TOA, opposite over adjacent. Opposite, adjacent. And then r squared plus equals x squared plus y squared. That's your circle equation as well. Distance from the origin. X squared plus y squared. Pythagorean theorem. A squared plus b squared equals c squared. All those things. So these are known kind of bridges, if you will, to go back and forth. Now, these 2 are really important. On FRQs, sometimes you'll get a point just for writing that down, even if you don't wind up using them at all. So make sure you know that x is r cosine theta and y is r sine theta. It also makes sense still because y is your up and down, that's sine. X is your left and right, that's cosine. So when it says convert from polar to rectangular, so we know that x is r cosine theta, y is r sine theta. We know that this is r and this is theta. So x is 2 cosine pi, y is 2 sine pi. Once again, lots of unit circles in this section. So x is -2, y is 0. So -2, 0. And that's the rectangular. Which totally makes sense. So if I'm talking about 2 pi and -2, 0. So if I go back to this, so if I were to go graph the point 2 pi, so that means I would face pi and I would walk 2 units. So there would be your dot. Well, now if you're making this a rectangular system, it's xy. So now we're calling that -2 to the left and then 0 up or down. So you wind up getting the same dot. So hopefully that gels with you. All right, so pi over 3, or square root of 3, pi over 6. So if I were doing this in a polar system, I'm facing pi over 6 and I'm walking square root of 3 units to it. So if I want the xy pair, essentially all you're doing is SOHCAHTOA. You know that your theta is pi over 6 and you're just finding the height and you know your radius. That's what the things are giving. So the formulas wind up being x equals r, which is the square root of 3 cosine pi over 6. Y equals the square root of 3 sine pi over 6. So cosine of pi over 6, 3/2. Well, when you multiply it by the square root of 3. So we got the square root of 3 over 2 times the square root of 3, which is 3/2. And then the sine of pi over 6 is your half. So you got square root of 3 times a half. You end up with the square root of 3 over 2. So my ordered pair would be 3/2 comma square root of 3 over 2. And what we're saying is that polar system is equal to that rectangular point. All right, you also got to be able to go backwards. So from rectangular to polar. So again, what this means now in rectangular is you go left one, up one. So some of us can just reason this out. Well, we should know that that angle is going to be 5 pi over 4, halfway between pi over 2 and pi, because I'm equal. This is one of the easier ones. And then the radius, well, it's Pythagorean theorem. So it's going to be the square root of 2. So that, if you're clever and when it's easy, you can really just rationalize this out. Now, if you wanted a formal way to do this, we know that my r squared equals my x squared plus my y squared. This is me finding the square root of 2. So r squared equals 1 squared plus 1 squared. So r equals plus or minus the square root of 2. That's your radius. That's what we did. That's very formal Pythagorean theorem. Now my angle, okay, so they're not always going to be exactly in the middle, so it's not as easy to figure out. So what we need here is the next equation that says tangent theta equals y over x. And again, these formulas are all right here in your notes. So tangent theta equals y over x. That's how we find your angle. So that means that tangent theta equals -1. So then you're asking yourself, well, where is tangent -1? -1, so the values need to be the same, but one of them is negative, one of them is positive. That puts you in quadrants 2 and in quadrants 4. So that gives me 3 pi over 4 and 5 pi over 4. So how can there be two ways to get to this one dot? Well, when you pair them up, you have the straightforward way, so the square root of 2 comma 3 pi over 4. Well, the tricky way to get there would be to face 5 pi over 4 and back into it, backwards. We're generally restricting ourselves from 0 to 2 pi, so like you could be like, well, add 2 pi, there's another one, add 2 pi, there's another one. And I'm with you, I feel you, but overall. This one's also trick. B is one of the other straightforward. So if it's 0, coordinate pair 0, 2. That's the xy plane, remember? Well, I'm done. I know that the radius is 2 and the angle's pi over 2, and you can just write your answer. But the process still works. So r squared equals x squared plus y squared, which is a little silly at this point. So 0 plus 4, r equals plus or minus 2. And then tangent theta equals y over x. Well, that's undefined. So now you're asking yourself, where is tangent undefined? And we remember that happens at pi over 2 and negative pi over 2. Or you could say 3 pi over 2 or whatever pi over 2 you want. And so why is it undefined there? Because tangent is sine over cosine. And where cosine is 0 makes tangent undefined. So cosine is 0 pi over 2. So an answer here would be your radius is 2 and your direction is pi over 2. Or you could say -2, 3 pi over 2. Or -2, negative pi over 2. All the same. All right, a little longer today. Convert to the rectangular equation to the polar form. So my kind of go-to equations, I'll rewrite them here for these two for you. They're on the front, but you might not have them printed. So x equals r cosine theta, y equals r sine theta, and then r squared equals x squared plus y squared. These are our equations to work with. So I'm going to just do substitution. So I'm going to replace x with r cosine theta. I'm going to replace y with r sine theta equals 2, and then x is, again, r cosine theta. So replacing all my x's with thetas and y's with thetas. And then I'm just going to simplify this system. So the r's go away, divide r through. So you get sine theta equals cosine theta. So now you got to be a little clever and think, where does that actually happen? So theta equals pi over 4 and 5 pi over 4. So this one's a little weird. So r's gone. So what is r going to be? That means r is not restricted. R can be anything. So they gave me a direction. So if I'm trying to rationalize what this is going to look like, you're going to face pi over 4, and you're going to face 5 pi over 4. R doesn't have a restriction. So you can go all the way towards it, and it's anything and everything in between. So what I have is a straight line here. Now that should make sense. If you go back to look at this again, if you just solved this, it's y equals x. Well, what does the line y equals x look like? It looks like the diagonal line through the origin with a slope of 1. All right, B, a little more complicated, not just a linear anymore. Hopefully maybe you recognize what that shape might be, but same kind of idea. We can see from our functions x squared plus y squared just equals r squared. Y is r sine theta. So r squared minus 2r sine theta equals 0. Well, here we are at pre-cal. You got to be able to solve trig equations with quadratics. So factor out an r minus 2 sine theta. I used to love these. So now you just set each factor equal to 0, just like it's a variable x. You get r equals 0, and then you get r equals 2 sine theta. I was setting equals 0, and then I got r equals 2 sine theta. So now you got to figure out, like, r equals 0 is nothing. That goes away. Here's your system for r. So now you know that r equals 2 sine theta. So x equals r cosine theta, and y equals r sine theta. I'm working from these equations and just plugging r in for r. And then you could clean those up a little bit if you liked. But we're in polar form here. And then you can go backwards from polar to rectangular. Same ideas here. X is r cosine theta. On all of these, if it's an AP question, just literally write these formulas down before you do anything else, because you're going to get a point for that. R squared equals x squared plus y squared. And you can convert. So if we know r, so we're looking for a rectangular form. This one's, honestly, changed my mind. These are all things you should have done already, but they're not really important to the calculus, so we're going to just let these go. Don't worry about it. Don't really worry about example 4 either. Not that important. Now, this is what is actually very, very, very important for us in calculus. You need to be able to sketch these. Okay, so we're going to start basic, just like we did with parametrics. And the very first way we ever sketch things is we plot points. So I got my theta and my r. So I'm going to go around 0, pi over 4, pi over 2, 3 pi over 4, pi. And we're going to see what this thing looks like. Now if I plug in 0, I get 2. Pi over 4, I get the square root of 2. I get 0, negative square root of 2. Plug in pi, you just get negative 2. You need to make sure that you can do that. Make sure you know your unit circle. So then I start plotting these things. So I got theta equals 0, r equals 2. So I face 0 and I go 2 units. So if I'm facing pi over 4, I walk the square root of 2 units. which is, somewhere in here. If I face pi over 2, I got 0. So this thing is kind of swooping around. If I face 3 pi over 4, that's over here, I go backwards root 2. And then if I face pi, I go backwards 2. So back where I started. So what seems to have happened is it has gone around, and it looks like a circle. So r equals 2 cosine theta. Let's graph these things. There it is. R equals 2 cosine theta. If I change the coefficient, so 2, I made it a 1, or if I made it a 4, remember r represents how far you are away from the origin here, or the pole. Well, so if cosine is 1, so cosine of 0 is 1, that means your radius is 4. So on my origin, that coefficient is your distance from the center. So if I make it 2, you're going to go 2 away from the pole, because cosine is 1 at that angle. And then this one as well, same idea. Oops, that's going to go away. Theta, radius. So I start with these, you're going to get 1. Now, these aren't so clean. So if you put them in it's 1 minus the square root of 2 over 2. And then pi gives me 1. So if I'm graphing these things, I got face 0, I walk 1 unit. I face pi over 4, I walk 0.29, so not very far. Pi over 2, I'm 0. So now I'm back on the pole. And then I leave the pole. Too far. Hold on. Face 3 pi over 4. I missed the pi over 4 on this one. I don't know why they like short change that line. Pi is 1. So I got a little hump here. So I got to keep going on this one. So 5 pi over 4 will give me 1 plus the square root of 2 over 2. So that one's further down. 3 pi over 2 is going to give me 2. I'm smelling symmetry here. And then back. And I'm getting this type of curve here. Now when I look at this, it's on Desmos. You can see it looks like this. All right, so what do you need to be able to do from all this? You need to understand the graphs. So the best thing for you to do would be to graph these things in your graphing calculator and go through. So you're going to have to hit mode, and you're going to have to go down to where we switched it to parametric. You're going to have to switch it to polar. And then when you go to graph it, it's going to give you R equals, and you're going to just type 2 cosine theta. Theta will be your new variable button instead of X. So you're going to need to work with your windows. When you hit window now, it's going to give you a theta min and a theta max. That's what's going to be enabling you to sketch these things out and draw it out. I'll kind of show you a little bit on the AP Classroom today, how you